Okay, hello peoples. Um, I just want to review or talk about the ATP synthase. The the ATP synthase is what changes ADP into ATP, and it takes energy to do that. So it's really interesting how they obscure the facts when they discover something, especially like in biology when they talk about the ATP synthase. What they're really talking about, what they're actually talking about, is an electric motor. They're talking, but they obscure it in language so that you think, oh, it's biology, it's just chemicals reacting. No, it's not just chemicals reacting. It's a battery that runs trillions of electric motors inside of us, and that's where we get our energy from. You don't think that we run around all day long by by magic. It's by energy, and the energy that we use is ATP. And the way we get the energy is little springs inside of us, basically. But I don't know if it's exactly a spring, but it's little energy molecules inside of us. But in order to get them to be sprung, then you have to compress them, or you have to, in other words, you take ADP, which is, let me see what they call it. They call it adenosine or diphosphate, and then they put, instead of a diphosphate, they put another phosphate in there, and it's a triphosphate. So, and this takes energy to put this stuff together, these molecules together, and then when it's released, it releases energy, and that's the energy that we run on. But the interesting thing here is how deceptive they are about it. And when I first saw the spinning electric motor inside of us, I was thinking, well, why aren't they telling people that we have electric motors inside of us? Because when they go to explain it, they said, oh, it's an uneven energy gradient. I mean, it's uneven gradient of ions, positive ions. Our electric motors that we use are negative electrons, and what's used in this situation is positive ions. Hello, Honesty Angel. So instead of, like when I was talking to Gnostic Books, he was saying the energy, I mean the electricity moves from positive to negative, but that's not exactly the case. It actually moves from negative to positive because we're using negative electrons to run our electric motors. But in the case of the ATP synthase, they use positive ions. So, but it's the same thing as a battery. It's the same thing. They call them, there's ion pumps. They have ion pumps that pump ions to one side of the membrane, and then it becomes an uneven gradient, and they flow naturally to the other side of the membrane through the ATP synthase powering the electric motor. But what that is, that's the exact same thing as a battery. Why don't they just say we have batteries that are charged up inside of us in the mitochondria, and those batteries inside of us in the mitochondria are what run the trillions of electric motors inside of us. Hello, Jesus is Lord. It's just amazing how they would like to obscure the facts. Because if you're honest, you're going to say, look, it's charging a battery. The battery gets charged up, and the battery runs ATP, electric motors, Sythase, which power the formation or the compression or the putting together the ATP molecule from adenosine diphosphate to triphosphate. And that takes energy, and then when it's released, there's a release of energy, and that's what gives us the energy that we run on all day long. Hello, Andreas Brammer. Hate to say it, but it's not a motor. It is electric motor. This is what I'm ranting about right now. It's a battery inside of the mitochondria, and it's an uneven gradient, which is the same thing as a battery. When you have a battery to charge your cell phone, you have an uneven gradient. You have the negative electrons that flow from the battery into the battery of your cell phone, which then powers your cell phone. It's a positive ion battery. Instead, the electricity that we use is electrons, but in the case of the mitochondria, it's positive ions, so that it runs from positive to negative instead of from negative to positive. It's a battery. You charge the battery. You have batteries inside it, and it runs literal electric motors and powers the formation of ATP. And there's no way you can get around it. And you might as well start saying it. An uneven gradient is the same thing as a battery. When you have electrons that go from one side to the other, it's the exact same thing as a battery. It's an electric motor inside of you that puts adenosine diphosphate and gets another phosphate and makes a triphosphate molecule, which is then appropriated by our bodies. Everything in our bodies, including our mind, our muscles, everything uses ATP for the energy to run on. They're spinning electric motors. Maybe we can have a discussion on this later, but they're spinning electric motors. They're powered by electricity, which is from charging up a battery inside of the mitochondria. And it's powering the electric motor to make the energy that you run on. So you run on electricity. You have electric power plants inside of you that power your existence. And there's no way you can get around it. There's no way you can get out of it. Okay, let's see. It says no way like a battery. It's a protein that behaves according to thermal noise. What's a protein? You're aware that ATP spontaneous will decompose to ADP and PI, meaning it does not get stored. Glycogen can be considered one. It's still what we run on. It's where we get our energy from is ATP, and it doesn't matter if it's not stored. It's being made as needed by the ions are being stored when it charges the battery inside the mitochondria. That battery turns the electric motor, which powers the formation of ATP, which we use on demand. Glycogen can be considered one. It's the problem gradient. It's a proton, exactly what I'm saying. It's an ion proton. It's a proton that generates the energy needed for the coupling of the phosphate. That's exactly what I'm saying. It's positive electricity that turns a motor, which powers the formation of ATP. It's electricity. It's a battery and electricity that turns motors inside of you, trillions of motors inside of you, to form ATP so that you can have energy on demand. Yes, Batteries store energy, but it's the mitochondria. The battery is in the mitochondria. The mitochondria, when you have an uneven gradient, that's what a battery is. It's an uneven gradient. But it's deceptive to be calling it an uneven gradient without explaining that's the same thing as a battery. When you have a battery, it's an uneven gradient, and you plug it into your cell phone, and the energy goes from the battery into your cell phone. And then when you charge up your cell phone, when you even out that gradient, uneven gradient, then you have power in your cell phone so that you can then run your cell phone by electricity. And it's the same thing in the case of the mitochondria. You have a battery that's charged so that you have an uneven gradient so that the protons move through the membrane by way of the motor and turn the motor. It's an electric motor. It's an electric motor that powers the formation of ATP, and there's no way you can get around it.